Okay, this is the inequality systems review for quiz 3.3. Number one has what I would call standard inequalities. They're in slope-intercept form, which means the graphing them shouldn't be too much different than graphing a normal line, except for how to shade them. Let's do the first one in red. This one says a y-intercept at -4, so I'm going to go down here to -4, and then every slope is a fraction, so 4 over 1 means I'm going to go up 4 and over 1. So you should be using a ruler for these, so your lines might look a little bit straighter than mine when I draw them. But this is going to be a solid line, so I want to connect these with a solid line. And then for shading, we need to go greater than. Greater than would be on the line and up from it. So I'm going to shade this line on the upper half of it. Like that. The other one I'm going to do in green. So it's the same format, just a couple different numbers. So I need to start at -3 this time, right here. And I need to go up 3 and over 1. So I'm actually having the same point right there. So I'm going to draw this line. Again, it's solid. Like that. The shading for it is also greater than. So from the line up. This is going to be weird because we have a whole lot of overlap in this one. So the overlap, you can see right here, right, that there's only green shading in between these lines here. And then down here, there's only red shading. So basically the overlap is starting on this line up here, and then continuing on the green line down here. So the overlap is all of this, all over here. This one's really weird because it's not what you'd expect. Most of the time you'd expect the shading overlap to be in between the two lines or something. But this one, the equations are very similar, the inequalities, excuse me, are very similar. So you end up with a whole lot of overlap in solution. And the only place where there is an overlap is in between the two lines. Okay, this one is one of the problems where one is set up most likely for substitution, and one is set up, or excuse me, for the intercept method, and one is set up for rearranging. I think the first one is set up for the intercept method because all these things are positive, and if I solve it like the x term by itself, it's going to be x equals 5. There's nothing to solve. And for the y term, it's y equals 5. There's nothing to solve. So I have my x-intercept on positive 5, and my y-intercept on positive 5. It's going to be a dashed line this time because there's no line underneath of that. So I have a dashed line going this way. And my shading is greater than. So I'm going to go and shade this thing greater than, which would be up from the line. So all of this area up here. So the other one I'm going to do in green, and this one I think is set up most likely to be rearranged. You could use the intercept method if you want, but you have to be careful the way you shade it. What I'm going to do is take this, I'm just going to subtract the x away from both sides. It leaves me with a negative y less than. You always put the x term first, and then the -3 after it. Now I'm going to divide everything by -1 to get rid of this negative. It leaves me with a positive y. When I divide by any negative, I have to reverse the inequality, so it's actually going to be greater than. And this is -1 divided by -1 is +1x, just x, and +3. So I'm going to go ahead and graph this now. I'm going to put this 3 on the y-intercept. And then I also need like a slope here of 1 over 1. So I'm going to have a point right here. It will also be a dashed line. And the shading for it, because I had to reverse the inequality symbol, will be greater than or up. So up from this line, it's going to be in this area. So maybe you can see that the overlapping shading that happens here is just in between these two lines right here. So I want to highlight this and then say that that overlapping shading is in here. I think this one makes a really good picture for seeing how overlapping shading works. All right, so number 5, one of the ones we didn't do in class, it has a couple of things that I think could potentially make it a little difficult. First off, there's 3 things in it rather than 2, so that already might make it at least a little longer to do. But also, I'm going to adjust the way I draw this a little bit because I need to make it fit on my graph. So I'm actually going to bring this all the way up here. And the reason I did that is because if I look at this inequality right here, I have a y-intercept of -10, and then I also have a slope that is going to make it go down 3 and right 1. So I'm going to have a line that's sort of way down here. So I need to make sure that I make it fit on my graph. At the same time, over here I have one that's +2 and I have to go up 3 over 1. So that one's got to be able to fit too. So I'm going to see if I can adjust this. I might even have to make it by 2s to make it fit. So I'm just going to count here real quickly to see if I can make this fit. So here is -10. If I started here, I'd have to go down 3 more. I'm going to be off the screen. So I'm going to choose to make the y-axis this time go by 2s. That'll make it fit. So I can move this back down a little bit. So I'm saying y-axis by 2. Just so that I can make these things fit on here. The x-axis can still be by 1s, it doesn't matter. So the first one I have to put on here is a vertical line. A plain x with no y tells you it's a vertical line. This is going to be a vertical line at -1, and it's going to be a solid line. So -1 on the x-axis right here. Solid vertical line. And the shading for it, left hand will be to the left, right? Where are all the things that are less than -1? Here's -2, -3, -4, there this way. So I'm going to shade this one all to the left. So let's do this next one. Again, remember, I'm doing this by 2s now, so the things fit. So when I say +2 for the y-intercept, I'm going to put it right here. It will be like 2, 4, 6, 8, like that. My slope is up 3 and over 1, so from here I'm going to count. Up 2, up 3, and then over 1. Right here. This one's also a solid line. And its shading is left hand, so down from that line. So down from the line is going to be all over here. So maybe you can see that really the only overlapping shading right now after the first two is right here in between these two lines. So all of this red out here I'm not going to need, and all of this green over here I won't really need either. All right, let's put this one on there. This is the reason why we had to scale it by 2, because we have this -10, so let's make it fit. Here's -2, -4, -6, -8, -10, right there. And then I have to go down 3 and over 1, so again I'm going to count. Here's down 2, down 3, and then over 1. That's it. This one is a solid line. And my shading for this one is going to go up because it's greater than it. So I'm going to have shading going all off in this direction. So it gets a little tough to see with all these colors in here. But really our shading overlap is very, very small here. It's just in here. It was below the green line, to the left of the red line, and above the blue line. It's just this little area right here. So again, when you start seeing a whole bunch of shading overlapping each other like that, or when you have multiple inequalities on the same graph, you're going to see that those overlapping shading areas get really small really quickly. Okay, this is number 7. I would say number 7 really, compared to the others, really isn't that bad now. But I am going to adjust this graph again. I have a +8 here that I need to make fit. Plus I have to go up 3 and over 1 from it. So I'm going to move this line down so that I can make that +8 fit on here. Do it right there. I think we'll be okay. So let's start with this first one. I'm going to do this one in red. I got a 3y here. I don't want that. I want just a plain y. So I'm going to divide everything by 3. That's going to give me y is greater than or equal to 2 over 3, which is good because I'm on slope. 2 over 3x minus 1. So I'm going to put my point at -1 to start. Then I'm going to go up 2 and over 3. I got a solid line here. And greater than shading is up from that solid line. We're going to have a whole lot of the same shade here. And then the other one I'm going to do is green. We need to start at +8. 1, 2, 3, 4, 5, 6, 7, 8, all the way up here. See, because I moved this line down, it made that easy to fit on there. Then I'm going to use size of the line up 3 and over 1. I need a solid line there. So when I shade this one, again, it's greater than, so I'm going to put here and go up from the line. So it's all of this area over here. So if you've made your graph big enough that you can actually see where these two lines down here intersect, then the overlapping shading basically occurs from that intersection over. So it's all of this over here where the overlapping is. Quite a lot of area on this one. All right, on to the last one, number 8. When I look at this one, I see that I got to make a -8 fit on the y-axis and a -6 fit on the x-axis. So I'm going to adjust this thing again just to make things work for me a little bit. So the first thing I'm going to do is move this up so that I can make that -8 fit in there. I'm going to move it this way a little bit so I can get the -6 on it too. With the x. So let's do the first one in red. That's a horizontal line where y is -8. I'm going to count down to -8. here, and I need a horizontal solid line right here. And I need greater than shading, which would be up from the horizontal line. So I got greater than shading up from that line. Which again is quite a lot of. So we're going to do, I'm going to do this vertical line next, because it's easier. X is greater than -6. I need a dash line where X is -6. 1, 2, 3, 4, 5, 6 on the negative. So I got a vertical dash line right here. And I need greater than shading, which is to the right when it's a vertical line. I want to shade this way. So maybe you can see that right now, my overlapping shading is basically, you can see this is all green down here, and this is all red over here. The shading is sort of this big rectangle right over here, right now, all of them. Let's see if this one takes that and changes it at all. I think this is set up perfectly for intercept method. I can say x equals 4 and y equals 2. Like if you take this away, x equals 4. If you take this away, 2y equals 4, so y is 2. We need a 4 on the x-axis, that's actually going to be right here, and a 2 on the y-axis, right there. We need a dash line because it's a normal inequality. I'm going to draw in a dash line this way. And then the shading for it would be less than, or in other words, down from that line. So the shading is all down that line, all this way. So it's really tough to see when you've got shading going all over the place here. But this one, I think you can see, kind of makes a triangle-like shape. You've got all of this here. Starts on this line. Goes down here to this solid line. And then we have this dashed line up here as a boundary. If you saw these two lines here, this one and this one, go over here, eventually they would intersect, and you'd have a really big triangle. That's what the actual shaded area all looks like. But as you can see here, it actually runs off of my screen a little bit. So even after I adjust it, I still didn't get the whole total picture. That's all right. It makes it sense for the graph that I drew. So it's all of that area in there. And so over and over again, the problems are nothing but just saying, where is the overlapping shading area? Right? And just putting the graph on there, shading them individually, and then finally looking at it and saying, where is my overlapping shaded area? And that's what I want to make stand out from BCAP.